All right, let's talk about something we see every single day, something that can be, let's be honest, super frustrating. The traffic light. They just kind of sit there, right? But what if I told you they're secretly the conductors of this huge, chaotic orchestra that is our cities? You know the feeling, right? It's like 3 in the morning, there's literally not a single car on the road, and you're just stuck staring at a red light. You're thinking, why? Just why? Well, that exact question is what we're going to dig into today. Because believe me, there's a whole lot of tech and thinking going on behind that little red light.
Okay, so to really get where this technology is going, we've got to look back at where it started. For a long, long time, the quote unquote brain behind a traffic light, well, it was pretty simple. And honestly, kind of dumb.
So you basically have two main flavors. First, you've got your fixed timers. Think of these as just a simple clock. It runs the same exact pattern over and over and over. Doesn't matter if it's rush hour or the middle of the night. Super inefficient. Then you've got the slightly smarter version, vehicle-activated systems. These actually use sensors to know that you're waiting. I mean, that's a big step up, but they've got their own set of problems.
And the most common sensor, the one you've probably driven over a million times without even knowing it, it's called an inductive loop. You know those weird rectangular or circular lines cut into the pavement right before the stop line? Yep, that's it. It's basically a giant metal detector that's just buried right there in the asphalt.
So how does this thing actually work? It's actually pretty cool. A little bit of electricity is always running through that wire loop, and that creates a magnetic field. Now, your car is this huge chunk of metal, right? So when you drive over the loop, you mess with that magnetic field. The controller box on the corner of the street, it notices that disturbance and goes, got one, there's a car here. But here's the problem. It is far from a perfect system. Since it's just looking for a big piece of metal, it can totally miss things like motorcycles or bicycles. Ever seen a cyclist just stuck at a red light that will not change? This is probably why. Plus, the loop has no idea what it sees. A car, a bus, a truck, it's all the same to it. Oh, and if one of these wires breaks, you have to literally shut down the intersection and dig up the entire road to fix it. Total pain. So that brings us to the next big leap. People started asking, what if these lights weren't just lonely islands managing their own little intersection? What if they could talk to each other? What if they could work together as a team? And this, my friends, is the quest for the holy grail of traffic management, the green wave.
And that's where systems like Scoot come in. Yeah, it's a mouthful of an acronym, but the idea is simple. You link a bunch of traffic lights together along a major street. So instead of each light just doing its own thing, they're all part of a single, coordinated network, all working off the same game plan to move cars smoothly down the road. The whole point is to achieve perfect synchronization. I love how one research paper described it. The goal is for a driver to see a progressive cascade of green lights. What does that mean? It means if you're going the speed limit, you just hit green after green after green. No stopping. Yeah, that's the dream right there. Imagine a whole platoon of cars just flowing smoothly down a main street, never touching the brakes. It's a huge, huge boost in efficiency. But, and this is a big but, actually pulling this off in the real world with traffic coming from all directions, it is incredibly complicated. And that crazy complexity, well, that's where things get really interesting. Because to manage the traffic for an entire city, you need to process an insane amount of data, all at once. And that, it turns out, is a job that is tailor-made for AI. See, an AI doesn't just look at one intersection or even one street. It can see the entire city grid all at the same time. It can watch the flow of traffic in real time, see a traffic jam starting to form 5 blocks away, and start changing traffic light timings before it even becomes a problem. We're moving from a system that just reacts to traffic to one that actually predicts and anticipates. And a perfect example of this in action is Google's Project Greenlight. I mean, think about it. Who has more traffic data than Google? They take all that anonymous location data from Google Maps and use it to build a perfect digital copy of a city's road network. Then they just let their AI go to town, running it thousands and thousands of simulations to figure out the absolute best timing for the traffic lights. And the best part? They then give those recommendations back to the city's traffic engineers in a super simple, easy-to-use way. And the results they're seeing? They are just staggering. We're talking about a potential reduction in stops at intersections of up to 30%. Let that sink in for a second. That means almost a third of the red lights you sit at could just disappear.
And this isn't just about saving you a few minutes on your commute. It's a much bigger deal.
Every time you stop and start your car, you're burning extra fuel and creating pollution. So fewer stops means less wasted gas. They're estimating a potential 10% drop in emissions at these intersections. That's a huge win for cleaner air in our cities.
So, yeah, the future looks pretty amazing, right? AI and big data are teaming up to fix traffic. But it's not that simple. For these super smart AI systems to work, they need even better data, better eyes on the street. And the smarter this all gets, the tougher the questions we have to start asking ourselves.
So let's just look at the difference here. On one side, you have our old buddy, the inductive loop. All it can say is, yep, something metal is here. That's it. But on the other side, you have modern sensors like LiDAR. LiDAR is on another level. It's creating a live 3D map of everything happening at that intersection. It doesn't just see something. It knows that's a car, that's a person on a bike, and that's a pedestrian in the crosswalk. It even knows how fast they're going and where they're headed. The amount of data you get is just, it's a whole new world.
But with great power comes great responsibility. The second we start handing over control of our city streets to an algorithm, we open up a whole can of worms. We have to start asking really tough questions, like, are we accidentally programming our own biases into these systems? And when something inevitably goes wrong, who's to blame?
And look, this isn't some far-off science fiction problem. It's happening right now. A study from Georgia Tech found that some of these AI detection systems were worse at identifying people with darker skin. It's a classic problem. If your training data is biased, your AI will be biased. And when you're talking about something like traffic safety, that kind of bias can be deadly.
And that brings us right to the famous trolley problem, but with a high-tech twist. Imagine an autonomous car is in a situation where it's going to crash, no matter what. How do you program it to decide what to do? Does it swerve to avoid a group of pedestrians, even if that means harming its own passenger? Or does it protect its passenger at all costs? These aren't just thought experiments for a philosophy class anymore. They are real ethical dilemmas that someone, a programmer, has to turn into lines of code.
And on top of all of that, there's the privacy issue. A single self-driving car can generate something like 4 terabytes of data every single day. That is a mind-boggling amount of information. And it's not just any information. It's data about exactly where you go, when you go there, how fast you drive, everything. So who owns all that data? Who gets to look at it? And how on earth do we make sure it's kept safe?
So there you have it. We've gone from a simple clock on a pole to a massive, citywide AI network that's grappling with some of the biggest ethical questions of our time. So the next time you're just sitting there waiting for the light to change, look around. Think about what's really happening. That simple intersection is becoming one of the most complex and important battlegrounds of technology in our modern world. And the real question isn't just, when will the light turn green anymore? It's what or who is deciding to change it.